Hello. On today's video, I'm going to talk about the Cadillac 472-500 head bolts, honing, clearance on the piston. A couple of you guys saw this in the background and asked what I was doing. Now, most of you probably realize this is called a torque plate. And what it does is it mimics the stress put on the cylinder by the head bolt being torqued down. And I know a lot of you say, well, it's a high nickel block, it's low RPM, you don't need to worry about that. And you're kind of right. I mean, for the most part, you don't. Back in the 90s, when I built this, I actually ran a test because that question came up. How much does the Cadillac need to use a torque plate? And I ran a motor that we honed one side with a torque plate on a good hone from a automotive shop, machine hone. And the other side we ran without the torque plate. And then I ran the motor for quite a while. And after a few years, we swapped some heads around and I looked in the bores. And you could see a little shadow area from the side without the torque plate that where the bolt was stressing the cylinder wall. So this does help. Now, it wasn't major. Leak down was only slightly different from side to side. It did show up. So if you're really building an all-out motor, if you really need to make sure that ring is sealed, you're really concerned about blow-by in the motor, and you want to minimize that, the torque plate will help ensure that the bore is round when you hone it. Now that's providing you're actually taking some material out. Now in this case, I'm just hand honing. But on the stock Cadillac motor, the clearance from the factory on the piston, the skirt clearance, is as low as 1/2 of an inch. That's itty bitty. Now with wear, because these motors are 40, 50 years old, most of them that I take apart are around, they've worn down and they're probably at 1.5 thou, maybe approaching 2. Occasionally, if you get a motor that nobody took good care of, it could be higher than that, or something that's super high mileage. But they are high nickel, so they wear pretty slow. The problem is that wear is going to be in a taper form. So that extra thou of clearance is going to be towards the top of the bore. Now, if you're boring and honing a block, you can dial in whatever clearance you need for the particular piston you're using. In this case, I am reusing the stock piston, but I am honing it. Now, if you were just to do what's called deglazing, you could use a ball hone, which is just one of those, kind of brush-like looking with the little hone balls on the end of it. I am not very fond of those. The reason being is those conform to all the little highs and lows in the cylinder. And so you wind up not fixing any of that in the cylinder. In the case of me honing this, I'm using a at-home drill type, but more rigid hone. When you go to a machine shop, they're using a machine and the hone is even more rigid. And now, of course, with the new Super Race stuff, they've got CNC computer controlled that adjusts the pressure and dwell times and all that to make the cylinder perfectly square and perfectly round. And the better you get it that way, the better off you are. Now, in this case, because there wasn't a lot of wear, I'm having to pull like 1/1000th of an inch out of this cylinder with a hand hone. So I went ahead and put on the block plate. I have it. It just bolts on, just to ensure that it is round at where the bolts are. And this is taking me a while, but it's a budget motor. I'm reusing all the stock lower end, and so time is not my money. So yeah, it'll take me some time to work my way through it. I have to keep stopping and measuring to make sure that I'm not putting taper in it, that the bottom is opening up as much, because the bottom I have to take like a thou and a half out of, as compared to the top where I'm only taking a thou. So I have to dwell more at the bottom and try and get this thing as square and as round as I can with a regular at-home home. And that's all I'm trying to do. And the better job you do on this kind of stuff, the longer the motor's going to hold up. Now, you may be asking, why am I taking extra out? You know, if the factory clearance is a half thou and I'm already above that, then why not just deglaze it with a ball hone and throw in some no rings and call it good? Well, the problem is that half thousandths to even a thousandths is not enough clearance. You will find as you start running these performance-wise that that causes the side of the piston to start sticking in the bore. You'll start seeing scrape marks and gall marks along the skirt of the piston. That's the piston trying to stick in the bore. And the hotter you run the motor, so you know, if you're going to run boost, if you're going to run nitrous, if you're just putting on a big old mambo cam and porting the heads as far as you can, you know, you have to allow a little more clearance than what factory said, and the factory parts will hold up okay. I mean, yeah, if you're building an all-out motor, you're better off with a forged piston and maybe a better rod. But the stock stuff is really not that bad. A lot of guys will tell you, oh, the factory Arma-Steel rod is just a horrible rod. You really need a new rod. I've broken a bunch of them. Well, the rod doesn't break from the force of horsepower. The rod is breaking because this piston is trying to stick in the bore. And and it's not black and white. It doesn't stick and stay. It starts applying more and more grip to the sidewall of the cylinder, which puts more and more strain on the pin, the rod bearing, and the rod itself. And that's actually the cause of most rod failures. If you start taking motors apart and you find somebody that wrecked a rod, oh my God, I lost a rod. You know, and what you will find if you look through the pistons is you'll start seeing those gall marks down here on the skirt. That is the indication that the motor either got hot enough or something wasn't clearanced enough to where that piston was trying to stick and hold it from running. And that is the biggest failure. Now, extra clearance will cause, you know, more blow-by. And if you're worried about that, you know, and you have to run something, either a forged piston that has a lot of clearance, or even on a factory one, you could put in like a total seal ring and see if you can't keep the blow-by down with the extra clearance. Now, it's not leaps and bounds. It is sometimes noticeable, but it'll really help save the motor. I mean, people keep asking me for years, well, how'd you get away with RPM? How'd you get away with doing that? And it's a stock bottom end. I've blown up 4 stock bottom ends. Well, it's because I'm paying attention to some of this on like clearance. And that is part of what I'm doing here. This is a budget build, but I am going to put good heads on it. I am going to put a better camshaft in it. And who knows, I might put a little juice to it, or maybe I'll throw a little blower on it and make a few pounds of boost. So we'll have, you know, 500-600 horsepower on basically a stock motor. Well, like I said, the heat is the word. So I am just making sure I have enough clearance on the stock piston in order to do that. And the factory book will tell you 2 is absolute max. Well, as far as I'm concerned, 2 may almost be minimum. You know, 3, even 3.5 clearance on the side of this piston is just fine. And it'll run just great, and the blow-by is not going to be huge. You know, so the main reason Cadillac put such a tight clearance in there is to make sure that it wasn't rattly when it was cold. Now, if you're in a very cold environment, you know, if the motor's going to run ice cold, you know, clearances could be slightly different. But I've been running them this way for years, and I have had almost no trouble at all. And I have yet to lose a rod or wreck any of this kind of stuff because I'm making sure that the clearance is good. Now, once you decide what your clearance is and you figure out how to hone it. Now, like I said, I am kind of doing a home thing, and it is tedious, and I can get there. I've got years of practice, and I'm trying to keep the cost down. I'm using all stock lower end. I'm using as many stock parts as I can. You know, this is a budget build. This is not, you know, a $6,000-7,000 motor. I mean, I'm trying to keep it down. So I'm doing it the hard way. You know, you can still use a block plate, figure out what clearance you need so that the machinist knows what the bore size is supposed to be when he's done, and do it on a regular machine, you know, machine shop home. And that's exactly what we did to the Richard Holdner motor. The one he took to put turbo on and nitrous on, if you notice, it didn't stick a piston. Well, that's because I opened it up to 3,000 clearance because I knew he was going to do that. And these stock motors do not survive. I mean, he's done it to other motors, but a lot of them run a lot more clearance than the Cadillac does. And that's one of the points that you really got to pay attention to, even if you're running, you know, a stock motor. Now, if you're dead stock, 300 horsepower, 3,000 RPM, you know, you can run those tight clearances. Keep the temperature under control in the motor, and you're good. But on some of these, when you take them apart, a lot of times, even on the dead stock motors, you'll start seeing those marks when you pull a stock piston out. And a lot of guys wind up having to put other pistons in because of that. That's usually an indication that the motor got hot and it started to expand. And that's one of the things. If you're not going to worry about the clearance, then you really got to worry about the temperature. But like I said, I find that the 3000's clearance, or even just over, works really well. Plus, the benefit is you can get a nice hone and a fairly nice looking cylinder on a dead stock motor without having to swap in new pistons and whatnot, and you get a nice ring seal, and it does really well without having to buy a bunch of extra parts. And I've been doing this for years with stocker motors. I have run them way harder than most people, trying to find where the problems are, and that was one of the ones I found early on that has really helped me. Now, if you get back to the bolt and the clearance thing, you may or may not need to do that. I never could notice a big difference, but since I have it, I am going ahead and using it just because the more round this is at the top, the better off I am. So I'm just trying to do it as well as I can. If you're building a very expensive motor and you really want it to seal, I recommend you find a block plate. You know, some machine shops may have them, or you may have to buy one in order to do the motor. But that just ensures that the top of the cylinder is just perfect. If you're just building a regular motor, there's no worry about it. The other thing that comes up is the head bolt itself. Now, the factory head bolt is going to be way old. And some of them are in good shape, some of them are not. You're going to find some of those ones along the exhaust are looking pretty sad because a lot of hot exhaust temperature is going to take a lot of the carbon out of the bolt, and it's going to weaken the bolt. These bolts were as good as they could get back in the day when these motors were made. They are not a bad bolt, but they are old. And so if you find one like this one, it's not bad. The threads are in good shape. There's no corrosion on it. There's no heat cycling on it. It's actually a good stock bolt. But if you're going performance, the question becomes, does that even have enough hold down? And a lot of guys will either go to a Milodon or ARP stud. And I did that for quite a while when they first came out. I was way excited. Now, the only problem with the stud is if you're running the stock rocker arms, this top is bulkier. It doesn't completely clear. You may have to go to a smaller 12-point nut which I think the ARP set includes, but the Milodon set does not, in order to get these bolted in. And these are a lot tougher bolt. I mean, these are a lot higher quality. This was probably just above a grade 8 bolt on the factory bolt. And Cadco actually sells a replacement bolt set that is just a grade 8 bolt. And for a stock 300 horsepower motor, especially if your bolts are all messed up, that's a good bolt set, and it's not terribly expensive, and it will work just fine. It'll hold up. You won't have problems because you just don't need that much clamp. As you start putting more to the cylinder, you have more and more pressure. That pressure is going to try and push up on the head, and we only have 10 bolts. And even in Ford that had 10 bolts, like a 460, they went up to a 9/16 bolt. We only have 10 half-inch bolts. So the stock bolt in a performance application is not going to probably cut it. Most guys realize that, which is why they usually go to an ARP set. And by that point, you're also probably doing a different rocker arm set, and so everything works out just fine. A while back, Al at MTS had an idea, and I thought it was crazy at first. I was a diehard ARP man. He found these bolts, and it says right on the end of the bolt, I know you can't see it, but it says F911, made by Foremost. And this is considered a beyond grade 9 bolt. This is like, 180, 190 PSI bolt. And that's the same kind of material that's in this stud. And I had my doubts at first, but I ran a set of these. He sent me a set of these because he was so convinced it was the better way to go. It was half the cost at the time of the studs, and I ran them on a boosted motor that made quite a bit of power. And I'm going to tell you, this F911 bolt did better than the stud did. So that shows you the quality of these bolts. He was right. And I became very sold on these bolts, and I've used them on various things over the years. Now the drawback is Foremost quit making these. Now some of them are still out there kicking around. You might run across a MTS set of F911 head bolts. There's something to hold on to. That's a good bolt. Really works well. Now, you can still get what's called a grade 9 bolt, which is 180 PSI bolt. Stock bolt is probably like 170,000 PSI, just over. I'm pretty sure these F911s were like 190,000 PSI. I think these are actually, this is an L9, this is a grade 9 bolt. I have not run them to test them, but that's basically supposed to be the same as the F911 bolt. The 9 was to show that it was a grade 9 bolt. Like I said, I have not tested these yet, but in either case, if you're just running a mild thing and you don't want to go to studs, this might be worth considering. I mean, it's going to be better than a grade 8 bolt, without a doubt. Whether or not it's quite as good as a stud, I won't know until I actually run a set and see how well they hold up. Now, once we've figured out what fastener we're running, and you can see on this, I have L9 bolts on it. The reason I've torqued it down like this, and part of the reason I've used the torque plate, is factory torque setting on a head bolt is 115 pounds. Now, a good half-inch bolt torque setting is usually more like 130 pounds. So either the manuals all have it a little low, or Cadillac did not torque it up to what's considered normal value. Now, on a bolt, you have what's called the yield strength. And you may have heard of head bolts that go to yield. And that basically, think of a bolt as a spring. It's a really tough spring. And when you're pulling on it, when you torque it, it's pulling down. Torque to yield means you're going to the point where the stretch in the bolt may become permanent. It's stretching the spring so hard that you are distorting the bolt slightly. That's why torque to yield bolts are only one-use bolts, because once you take them out, they no longer can be torqued to that value and still have a integral bolt. Most bolts, even like the factory Cadillac ones, usually go to a torque value of about 70% or 75% of yield strength. So they figure out the point at which the bolt's going to give up, and then they torque it a little bit less than that. Now, the thing to realize is as you go up in bolts, say you go to an ARP stud, you went from a bolt that was maybe 170,000 psi to one that was 180 or 190,000 psi bolt. Well, that yield point goes up because it's a tougher bolt. That also means that the torque value that you can torque this to goes up. So instead of torquing at 115, you might want to torque at 130, or you might want to even torque at 140, because a standard 180,000, 190,000 psi bolt will torque with oil on the threads at 140 psi or 140 foot-pounds. So that's what it takes to get these down tight. And that's above the factory spec of 115. If you are putting in this stud and only torquing it with oil, not ARP, but oil, to 115 pounds, then you are basically under torquing the fastener. It's going in at maybe 60% of yield. So you're leaving more spring in the fastener, and that doesn't necessarily help you with clamp. And we only have 10 bolts. We have to worry about clamp. So even with these F911 bolts, I ran them at 130 foot-pounds of torque on the head. And that worked just great. I didn't blow out gaskets even at 7 pounds of boost. I ran boosted nitrous and it held just fine. So when you're going up in fasteners, you really got to start thinking about what your torque value is going to be at. In the case of this bolt, like I said, I ran them at about 130. L9, I'm on the fence. I'll have to try some things and think about it. But when you torque a fastener harder, that makes this distortion even more. That's part of the reason I have these in here, is I put these bolts in, I torque them to 130, and then I'm doing my hone. That's the whole purpose of the torque plate, is to mimic what's going to happen. If I only torque these to 115 and then I put them in on the motor and I torque them to 130, I'm just going to add more distortion down here, and the whole reason for the torque plate is useless. So you really got to think ahead about what fastener you're running and what torque value you're running. I mean, you want more clamp on the head. You know, you don't want to go crazy. You don't want to go up to the yield strength to the point where the bolt or the stud gives up. But you can plan out a little bit and get more clamp on the motor, and it'll hold the head gasket better if you're really going to start making this performance. And so that's my main thing, and that's what I'm doing here. Put in the bolts, I torqued them to 130, and then I'm honing out to get the clearance I need for the piston. And yes, for the most part, it's all stock, and it's still being done. You know, these little things are what help make these motors hold together better. And so think about what you're doing on bolts, and think about what happens when that bolt's in there. Now, you don't need to worry about extra torque on water pumps or anything like that. Your main worry is head bolts, main bolts. If you ever look at a rod bolt, the reason they have a stretch value is because that's taking into effect yield without taking into effect torque. You're stretching that to a certain yield point. Again, usually 70%. So anyway, that was the video. This was probably a little longer than most, and that's how it goes. I'll talk to you later. Bye.